Welcome to session 2 of unit 5th in mechanical measurements. This session is about density measurement. The content of this session are the first one is recap of previous session, that is session 1, that is about humidity measurement. Next is introduction to density, density measurement by hydrometer. Next, advantages of hydrometer, then disadvantages of hydrometer, and finally specialized hydrometers. So first we shall discuss about recap of previous session, that is about humidity measurement. The humidity may be defined as the amount of water vapor present in the air. It is expressed in absolute basis or relative basis. The unit of humidity is grams of moisture per meter cube of air. Absolute humidity is defined as the amount of water vapor in a unit of volume of air, that is 1 meter cube of air. Then relative humidity is defined as the ratio of the amount of water vapor actually present in the air to the greatest amount of water vapor possible at the same temperature. The device which is used to measure the humidity is known as hygrometer. There are different type of hygrometers. They are psychrometer, electrical hygrometer, dew point hygrometer, and hair hygrometer. In them, the most popular type is hair hygrometer. The hair hygrometer use human hair as a humidity sensing element. This human hair expand linearly on absorbing the moisture from the surrounding air. This expanded hair moves the arm and link in hygrometer. In turn, this link moves the pointer on a calibrated scale. Thus, the humidity can be measured directly on a calibrated scale. That is about how the humidity is measured by hair hygrometer. In this session, we shall see about density measurement. Coming to the introduction to the density. The density may be defined as mass per unit volume at a given conditions of temperature and pressure. The SI unit of density is kilogram per cubic meter, that is kg per meter cube. The density is not same for all the materials. It varies from material to material. The density measurement is very important because it decides the ultimate load of the component or assembly. The density varies with the temperature and pressure. At the same temperature, with the increase in pressure, the density of the material increases. Conversely, at same pressure, with the increase in temperature, the density of the material will decrease. Next, we shall see about specific gravity. The specific gravity, or it is also called as relative density. The specific gravity or relative density is the ratio of the density of a substance to the density of a given reference material. For liquids, the water is taken as a reference material. The specific gravity is unitless. If the relative density of a material is less than 1, then the material, it means the material is less dense than the water and it will float in it. Whereas when the relative density is of a material is more than 1, then the material is more dense than the water and it will sink in the water. That is about specific gravity. Next we shall see about hydrometer. This is the figure shown in on the screen is hydrometer. Hydrometer is an instrument used to measure the relative density of liquids in the open vessels. The hydrometer consists of a sealed hollow glass tube with a wider bottom portion for buoyancy. The figure we can see there, it consists of a glass tube and at the bottom we have got the bottom portion is wider, that is float which is wider. Then a ballast such as lead or mercury for stability. Ballast means a heavy material which give stability. So we can see below the float there is a weight which is nothing but a lead or mercury which is attached so that it gives a stability to the hydrometer. Next it has got a narrow stem with the graduations for measuring. So in the figure you can see there, there it is written calibrated stem. It is nothing but a narrow stem which has got graduations. That graduations are calibrated directly to the relative density of the liquid. The main parts of hydrometer are one is calibrated stem which has got graduations. The next is float, that is a wider bottom portion which is meant for buoyancy. And the third one is ballast or uh, heavy material which is weight which is attached for stability which gives the stability to the hydrometer. The hydrometer makes use of Archimedes principle. So now let us see what is the Archimedes principle. Archimedes principle states that the upward buoyant force exerted on a body immersed in a fluid is equal to the weight of the fluid displaced by the body. That is, the buoyant force is the upward force exerted on the object which is immersed in a fluid. So, the Archimedes principle is illustrated with one example there, which is on the screen. There, the 5 kg weight is immersed in a liquid in a jar. So in the next second figure, we shall see we can see there the 5 kg the weight is 5 kg weight is acted by a upward force which is called as a buoyant force which is equal to 2 kg. So as the buoyant force is 2 kg, the exact amount of exact weight of the fluid is displaced by the body. That is, yes, we can see there in a small jar at the uh, beside of the big jar. You can see there 2 kg of water is collected outside. That means the upward force is in that figure, the buoyant force experienced by the 5 kg experienced by the weight is 2 kg. So the same amount of same weight of the fluid is displaced by the body. That is the Archimedes principle. The hydrometer works on the Archimedes principle or principle of buoyancy. Next, we shall see about working of the hydrometer. To measure the relative density of a required liquid, the liquid is poured in an open vessel. Then the hydrometer is gently placed, gently means quickly placed into the liquid until the hydrometer floats freely in the liquid. Then the point at the point or graduation mark on the stem at which the surface of the liquid touches, that is the graduation at which the surface of the liquid touches, is noted down. That graduation or reading correlates to the relative density of the required liquid. The depth to which the float of hydrometer will sink depends on the density of the liquid under measurement. Greater the density of liquid, lesser the depth to which float sinks. That is, if the density of liquid under measurement is more than the density of the reference material, then the float of the hydrometer will sink to the depth at lesser will sink at lesser depth. Whereas if the density of the liquid under measurement is lesser than the reference material, then the float of the hydrometer will sink to the greater depth. That is about how the relative density is correlated with the hydrometer graduation, and how the measurement is measurement of the relative density of the liquid is done with the hydrometer. Coming to the advantages of hydrometer. The hydrometer is very simple in construction as well as in operation. There is no any complicated procedure in operating it. The second one is it gives quick measurements. That is, much of the time is not required by operating the hydrometer and taking the relative density of the required liquid. Then it is an inexpensive instrument. That is, the cost of the hydrometer is not more. Coming to the disadvantages of hydrometer, the first one is it has a very small measuring range. Range is nothing but the minimum value and maximum value which can be measured by an instrument. The next it is a breakable glassware. That is, the hydrometer is made up of glass, so it has to be handled very carefully. So next is it has limited accuracy. The accuracy is limited with the hydrometer. Next one is the last sample volume is required. That is, to measure the relative density, we have to take large sample volume of a liquid, then we have to pour in the jar. That is the disadvantages of the hydrometer. So next is specialized hydrometers. Specialized hydrometers are the hydrometers which are named for their use. So some of them are, the first one is lactometer. Lactometer is a hydrometer which is used for measuring the fatness of the milk. We can see the lactometers in the milk dairies where it is used to check the fatness of the milk. Lactometer is nothing but it is also a hydrometer, but as it measures the fatness of the milk, it is the name is given as a lactometer. Similarly, the next one is saccharometer. The saccharometer is also a hydrometer which is used to measure the density of sugar in the liquids. So next one is alcoholometer. It is also a hydrometer which measures the alcoholic strength of the liquids, especially in the spirits. The next one is salinometer. Salinometer is also a hydrometer which measures the salt content of the feed water. So that is about specialized hydrometers. So the summary of this session is the density is defined as mass per unit volume at a given conditions of temperature and pressure. Density varies from material to material. Density varies with temperature and pressure. The measurement of density is very important because it decides the ultimate load of the components or assemblies. The specific gravity, or it may be called as relative density, it is the ratio of density of a substance to the density of reference material. For liquid, the water is taken as a reference material. The relative density of liquids is measured by an instrument called hydrometer. Hydrometer works on the principle of buoyancy or Archimedes principle. The main parts of hydrometer are graduated or calibrated stem, Second is wider bottom portion, that is float. And the third one is the ballast or the weight, which is meant for stability. For measuring the relative density of the required liquid, the hydrometer is gently placed in the liquid in a open vessel until the hydrometer floats freely. Then the graduation mark on the stem of the hydrometer, which touches the surface of the liquid, is noted. This graduation mark correlates the relative density of the liquid which is under measurement. That's how the density is measured by the hydrometer. Thank you for watching this session.